This is Algebra 1, Semester 1. It's the second unit called Inequalities. It's the fifth lesson called Multistep Inequalities. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So before we get into the actual problem set, let me try to demonstrate how to find those notes. That can be difficult for some students. First, the website. Here's the actual address, creatormath.weebly.com. Type that into Google. You should be able to find this homepage, hopefully. There you go. Once you're on that homepage, you're in the right place. Scroll down. Any questions on comp book, scroll down on that homepage until you see comp book. Please follow all the directions, watch all the videos, follow all the due dates, put everything where it goes, 5 things on the cover, what goes on page 1, and then we go on to notes here on the tab of the class you're in. In this case, we're going to Algebra 1. This is where you're going to find all of the vocabulary, the notes, the video lessons, and the problem sets. All right, so if you're not getting 100% on all of your vocabulary practices, you may not know that there is a complete PDF with all of the vocabulary words we study for the entire year in this class. It is downloadable to your device. It is searchable by your device. Just Google, how do I search a PDF with whatever kind of device you have. It's different for different devices. We're going to scroll to the semester we're in. This is the one for the video we're on. Here's the table of contents. You should have already copied the entire table of contents into pages 2 through 6 of your composition book. If you haven't already, please stop what you're doing now and do that. Watch the videos back on the home page as we just discussed. Now let's go down and find the unit. So here's the unit here. These are the lessons within it. There's 7 lessons within it. We're on number 5 right here. Number 5 says multi-step inequalities. These are the page numbers where the notes go. Here are the notes right here. But these page numbers, don't take this video's word for it, but go back and find the original table of contents at the time you're viewing this. These page numbers probably will have changed. So you're going to open notes. Sometimes I have to open it twice on my device, you guys, but if I see it clear up, no, it's not clearing up. See that? This is going to be one time when I go back, reload number 5 again, and knock on wood, yes, it's always loaded by the second time with me. So probably 20% of the time I have to click it twice, but every time it's loaded on the second time. You should be able to expand it. It's going to teach you how to do some inequalities. These are multi-step. We're going to go over the problem sets here. Teaches you how to flip things. Talks about rotating entire statement. Talks about graphing it on a number line. These notes go in your comp book. Vocabulary are, what is an inequality in algebra? It's greater than or less than, and there are greater than, less than, greater than, equal to, less than, equal to, the symbols, and some other things that go in your notes, like combined like terms, what an open dot means, a solid dot means, and what equality is in math and what an inequality is in math. All right, so those notes go in your comp book. With that background, now we're ready to do the problem set, and I'm going to explain to you a little bit more as we go through the problem set. These are all basically review. We've dropped them in each assignment. So given this, if you have this, what is it? It's a greater than. You describe it based upon the open being to the left, from left to right. It's larger first, so that's a greater than. If it's like this, it's a less than because you come to the smaller side first as you're moving from left to right. If we know what a greater than is, then we should know what a greater than or equal to is. That's 2 things. It's both greater than and equal to. It's 2 conditions. This would be a less than or equal to. On a number line, what does an open dot mean? Open dot means the value is excluded. So if you have a number line, and this is 5, and it's an open dot, it does not include the 5, right? So the value is excluded, right? Now they're going to ask us, what is a solid dot? Solid dot means the value is included. So if you had a number line and this was 5 and it was a solid dot right here, right, it would mean this is included. So you would have to have an equals in your statement too. We'll cover some of those. Given a parentheses in set notation, what does it mean? Parentheses means the value is excluded. So if we have this 8, comma, 13 here, this parentheses mean it doesn't include 8. That would be like an open dot in our notation here. Okay, the solid dot would be like a bracket. So what does a bracket mean? It means the value is included. This would be the 8 is not included, and the x is between 8 and 13. The 13 is included because of the bracket, and that would be the x is less than or equal to. You would need an equal to in your equality statement. Again, we'll cover that here a little bit more in a minute. And we've covered it on prior lessons, by the way. This is the 5th lesson, so we're going a little bit quick. Given a positive infinity, how is it read? Positive infinity. That's off to the right, you guys. Given a negative infinity, how is it read? Negative infinity. That's off to the left. On a number line, to the right is positive, to the left is negative. And you can continue all the way to infinity to the right, or continue all the way to infinity to the left. So is infinity a number? No, infinity is a concept that numbers either increase or decrease in the form of negative infinity forever. So you can't just pick a number, like you can't say a billion and say that's infinity. It's not, right? A billion's just on the way to infinity, and 10 billion or 100 billion or a trillion is all on the way to infinity. You can't pick a number. Infinity is not a number. It's a concept. It's an understanding of an idea in our mind that we can understand. Things can increase or decrease forever. So solve the following inequality. Okay, so we're straight into multi-step inequalities. So 5 times x plus 4, and we're going to distribute these. So we get 5x plus 20 here, less than 35. And we're going to subtract 20 from both sides. So just like solving an equation, the only complication comes in is if we divide or multiply by a negative. And we'll show you some of those in a second. So these are gone. This is 15 is less than 5x. Divide both sides by 5. Let's come over here. And we got x on the right is symbol in this same orientation, right? 15 divided by 5 is 3. Now, when we flip this, the large side is toward the x. The large side must remain toward the x. In other words, you flip the entire statement, including the sign flips. So it's 3 is less than x. We read it from this direction. We still read it from this direction. 3 is still less than x. It has to read the same from either direction. X is greater than 3. 3 is less than x. That makes sense. One being from one side, one being from the other side. So 3 is greater than x. Then on a number line, if x is greater than 3, let's say this is 0, this is 3, it would be an open dot off to the right. And if it's set notation, we want a parentheses on the 3 because it is not included. It's greater than 3. It's not greater than or equal to. So 3, and it goes up to the right forever to positive infinity. You have to use a parentheses. You can't use a bracket because infinity is not a number. So you cannot bracket it. It cannot be included. So 3, parentheses 3, positive infinity. These two answers. All right. Okay, solve this one. 10x minus 7 is less than or equal to 12x minus 2x minus 3. Well, 12x minus 2x are like terms, so I can say 12x minus 2x is 10x minus 3. Repeat this on the left. It looks like I'm subtracting. Let's do this. Subtract 10x from both sides, and look what happens. Okay, let's get straight to the meat on this one. This is 0. This is 0. There's no more x's left in this. When there's no more x's left in this, it's all real numbers. Let's test it out. This will be a little bit annoying, but let's test it out. Let's go to this line right here. Let's put in 0. If it's 10 times 0, that's 0. 10 times 0, this is 0. You'd be left with negative 7 is less than or equal to negative 3. Is that true? Sure. Let's put in 1. You'd have 10 minus 7 would be 3. 10 minus 3 would be 7. So is 3 less than or equal to 7? Yes. So we can keep plugging in values for x, and if every one comes up right, it's all real numbers, and the way we know that through this solution is these disappear with zeros. All right. Okay, let's go to the next. Negative 10 is greater than 2 times x minus 2 here. So 2x minus 4, negative 10. Let's add 4 to both sides. We get a negative 6 is greater than 2x. Divide by 2, divide by 2. Let's go over here. We get x is, keep the symbol in the proper orientation. Negative 6 divided by 2 is negative 3. Now we're going to flip it. X, see how the small side is toward the x? Keep it that way. It's got to flip also. The sign flips also, and the negative 3 can flip to this side. right? So x is less than negative 3, right here. Done. All right. Let's go to the next 5 times x minus 3 is less than or equal to 5x plus 20. So these go here. 5x minus 15 is less than or equal to 5x plus 20. I see a 5x on both sides, so same thing's going to happen here. If we subtract 5x from both sides, 0, 0. All real numbers, you guys. All real numbers. All right, and just start plugging in numbers. Plug in, like, let's go to this line here. It's a little bit easier. Plug in a 0. 0 and 0 would be negative 15 is less than or equal to 20. Check. And just keep plugging away, and you're going to find that all real numbers work. There's no number you can't plug in that won't work. All right. 8x plus 4 is less than or equal to negative 2. X minus 32. So multiply across these in a distributive fashion. Negative 2x plus 64, and it's positive because of the two negatives. A repeat on the left. Let's add 2x to both sides. Gone. This becomes 10x plus 4 is less than or equal to 64. Let's subtract 4 from both sides. 10x is less than or equal to 60. Divide by 10, divide by 10. And we get x is less than or equal to 6. X is less than or equal to 6. You know what? Let's go back up here because I didn't finish this one. Focus, please. There we go. If x is less than negative 3, let's put it on a number line. So here's 0. Here's negative 3. Less than means open dot, and it's going off to the left forever, okay, on our number line. If that's true, we need set notation. So I'm going to start on the right this time and say negative 3 is not included because it's an open dot, comma, it's going down forever to the left, and that can't be bracketed because it's got to be parentheses because infinity is not a number. So parentheses, negative infinity, comma 3, and I would like to see this as a negative 3 here, okay? That needs to be a negative 3. All right? So negative 3 there. I'll make sure that's corrected before you do it because this is negative 3, right? This is negative 3, so less than negative 3. Can't just switch to positive 3, and I don't see any other options there. All right, that's that one. Let's go down to this one now. X is less than or equal to 6. If this is 0, this is 6. Now we need to include 6 with a solid dot because it's less than or equals to, and it's going down to the left, to the negative forever. So this time I'm going to bracket the 6 because it's included, and I'm going to say negative infinity and parentheses because I can't bracket an infinity because it's not a real number. So bracket parentheses negative infinity, comma 6 bracket. There we go. All right, 2 answers are right here. All right, make sure you're matching up the title of the video with the title of the problem set you're doing. Algebra 1, Semester 1. This is the second unit called Inequalities, and the 5th lesson called Multistep Inequalities. All right, and it's on creatormath.com under the Algebra 1 tab. Hope this helps.